A very good morning to all my dear students. I hope you all are fine and safe, and welcome to our first online class in geography. Now the first lesson which we will be starting up is representation of geographical features. So let's start the lesson. Geographical features are naturally created features of the earth. They are of two types: natural, which includes landforms and ecosystems, and artificial, including human settlements and other engineered forms. Hence, these features are represented in different ways, so let's study them. In the first picture, we can see a globe. Now, a globe is a spherical model of the earth. It shows the shape of the earth correctly with very little variations. It shows correct positions and places and gives an idea of meridians of longitudes and parallels of latitudes. In the next picture, we can locate the North Pole and the South Pole of the earth and also the prime meridian. Now, prime meridian is a line of longitude which is at 0 degree. It divides the earth into two hemispheres, that is eastern and western hemisphere. In the next picture, we see the lines of longitudes. Now, lines of longitudes are imaginary circles perpendicular to equator, and these have same center. They join the north and the south pole and pass through a particular place. In the next picture, we see the equator. Now, equator is an imaginary line around the middle of the earth. It is one of the lines known as the line of latitude. It is at 0 degree and it divides the earth into two hemispheres, that is northern and southern hemisphere. Besides the equator, there are other lines also which are also known as the parallels of latitudes. Now, these are imaginary circles parallel to equator. They have varying centers and these central points lie on the same line. In the next picture, we see a map. A map is a representation of Earth's features on a flat surface. It is a conventional drawing of Earth's surface or a portion thereof showing countries, rivers, mountains, political boundaries, etc. Maps use symbols and colors to represent features of an area, simplifying the real world. Now, maps can be of three types: physical, political, or thematic. Physical maps show location and topography or shape of the Earth's land features. Political maps provides the boundaries and locations of political units such as countries, states, counties, cities, and towns. Thematic maps emphasizes a particular theme or subject such as climate, natural vegetation, population density, or economic activities. Next, we come to the scale of map. A scale is the most important part of a map. Map will be a mere diagram or sketch if it is without scale. Hence, the scale of the map is the ratio of distance on the map to corresponding distance on the ground. It is a part of a map that compares distance on a map to distance in the real world. A drawing that is made according to scale will be an exact copy of the real object, but will be smaller or larger than the real object. It is very important to have a scale on the map to show the actual position of different places. As maps are always reduced in size, they are drawn to scale. For example, in the next picture, you can see the scale written as 1:24,000, which means that 1 unit of measure on the map represents 24,000 units on the Earth's surface. Map scales can be expressed in three ways. First one, verbally or in the form of a statement. Then, as a form of ratio or representative or numerical fraction. And as linear scale, also known as the plane or the graphic scale. So let's study them one by one. The first one is the verbal scale. Verbal scale, also referred as a word statement or scale expression, where words are used instead of numbers to express the scale. The verbal scale can be thought as a translation of representative fraction into words. For example, 1 centimeter to 1 kilometer, meaning that 1 centimeter on the map corresponds to 1 kilometer on the ground. It is shown on the map by printing 1 centimeter to 1 kilometer. Units may vary from place to place in this method. It is a direct, simple and easy method of expressing the scale. The next one is the linear, also known as the plane or the graphic scale. A linear scale is usually present on most maps. It tells us how much map distance represents a certain real distance. Then the linear scale is used to describe the distance relationships between maps and the real world. It is a form of an illustration to use to depict the distances on the map in common units of measurement. Now the graphic scales are quite useful because they can be used to measure distances on a map quickly. Then linear scale is a special kind of a ruler that is divided into units of distance. And with this type of map scale, you need to use a linear line as a reference to determine how many kilometers 1 centimeter would represent in real life. A linear scale looks like a small foot ruler drawn at the bottom of the map. It is divided into primary and secondary divisions. The length of each division represents a certain distance on the ground. With this method, distances on the ground can be directly measured and read off from the map by using a piece of string, paper, or a pair of dividers. The scale remains true even after reduction or enlargement of map. It should be geometrically divided and subdivided. The units are in round number, which is normally a multiple of 10. Now next we come to is the numerical or the representative fraction. Now in this, a fraction is used to express the scale. Hence, a representative fraction is the ratio of distance on map to distance on the ground. In this fraction, the numerator is always 1 and shows the map distance, while the denominator shows the actual ground distance. If the unit of measurement on the map is in centimeter, the units for corresponding distance on the ground will also be in centimeter. For example, if a map has an RF of 1:20,000, it simply shows that any length on the map represents 20,000 times that length on the ground, whether it is in centimeters, inches, or feet. This method is generally used because it can be indicated by any unit of measurement. It can therefore be used by any country according to its own unit of measurement. It is thus referred to as the international scale. Now let's see an example. As RF is the distance on map upon corresponding distance on the ground, and for example here a scale is given 1 centimeter is to 5 meters, and we have to find the RF. So RF is 1 centimeter upon 5 meter. Now we'll convert 5 meters into centimeters, which will come to 500 centimeters, and the ratio will be 1:500. Hence the RF will be 1:500. Now let's study some conversions. Now the first one will be converting a representative fraction to a direct statement scale. To convert RF of the scale to a direct statement, we divide the denominator by 1 lakh to change into kilometers. And to change it into meters, we divide it by 100. Now as the units have to be same, so 50,000 when divided by 1 lakh comes to 0.5 kilometers, or when divided by 100 comes to 500 meters. The second example also you can see that 440 has to be converted into meters, so it is divided by 100. Now next we come to converting a direct statement scale to an RF scale. To convert from direct statement to RF, we multiply the number of kilometers by 1 lakh, and if we have to convert it into meters, then we have to multiply by 100. Now see to the example, 1 centimeter is equals to 2.5 kilometers. Now as the units have to be same, so 2.5 will be multiplied by 1 lakh, which will change to centimeter, and hence it will become 1:2,50,000 centimeters, which is expressed in the form of a formula, that is the distance on the map upon distance on the ground. Now in the next example, you can see the conversion of a statement scale, that is 1 centimeter to 220 meters. We have to convert it into a representative fraction. So we are converting 220 into centimeters, so it is multiplied by 100, and hence it comes to 22,000 centimeters. Now when we put it into the formula, it changes into 1:22,000. There are 4 major directions: north, south, east and west, which are also called the cardinal points. These directions can be subdivided as northeast, northwest, southeast and southwest. All the topographical and other geographical maps are oriented north or shown by an arrow pointing towards north. Once north is located, it is easy to find other directions. On the maps, 3 types of norths are given: true north, magnetic north and grid north. Let's study them one by one. True north is the north according to Earth's axis. It is also known as geographic north. It is a line which joins the North Pole and the South Pole. It is a direction which points towards North Pole and remains constant. Now North Pole may be found by means of pole star, sun's shadow and magnetic compass. Pole star is the brightest and the steadiest star that can be seen in the sky. It is always situated in the north and helps in finding the direction. Now we come to sun's shadow. The shadow is a dark real image formed when light coming from sun is blocked by an opaque object. The movement of the sun helps to find true north. Then we come to magnetic compass. It is an instrument used to find direction by means of a needle that always points north. The compass case is made of non-magnetic material like brass, wood or plastic and is sealed by a cover glass. Inside the case, a magnetic needle is balanced and at its center on a pivot so that it may swing freely. On the bottom of the case, beneath the pivot, there is a printed dial showing the points of the compass. When laid on the flat surface, away from anything, made of iron, the needle swings from side to side and finally comes to rest, always pointing in the same direction, which represents the northern direction of the particular place. To find direction by magnetic compass, the map is laid up flat on the ground and the compass kept on it close to the magnetic meridian printed in the margin. The map is turned until the magnetic meridian is lying parallel to the compass needle. The north to which the compass needle points is magnetic north, which differs by a few degrees from the true north. This small deviation is called the magnetic declination or variation. Now, magnetic compass helps the navigator and the surveyor and the explorer. Then we come to the other type of north found on the map, and that is the magnetic north. It is a north indicating the magnetic north pole. It is a direction towards which the magnetic needle points. The magnetic north is different from true north. The poles are situated away from geographical poles. The magnetic needle of a compass always points towards magnetic north. This direction goes on changing according to place and time. The angular difference between the magnetic north and true north is known as magnetic variation or declination. Then we come to the other north, that is the grid north. Now the north of the grid easting is called the grid north. It is a navigational term referring to the direction on northwards along the grid lines on a map. Then we come to bearing. Bearing is a horizontal angle between the direction of an object and other object. It is an angular measurement of direction in clockwise order, starting point being north. The modern compass, used in surveying and for navigation, is marked in angular measure. The circle of the compass card is divided into 360 equal parts, each one called a degree and numbered in clockwise direction from the north point. Thus, east becomes a bearing of 90 degree and south 180 degree and west 270 degree. With this, we come to an end of the first part of the lesson. The next part will be shared in the next video. Just go through the video again for a better understanding. Till then, stay safe, stay healthy, and have a good day. Thank you.